Here is a solution, or rather suggestion, for the test problem I gave you. Now the problem was, Sarah and Tom are riding their bicycles home from school. Sarah leaves immediately. The graph shows the distances traveled. Now here's a graph. It's a time and displacement graph, where time is on the x-axis, time is the independent variable, and distance is along vertical axis, and it's given in kilometers. Now each unit of time is 5 minutes, and on the distance side we have each unit as 1 kilometer. Now we need to find what is their respective speed, and we need to describe their trip home. So they are traveling from school to home, they're riding bicycles, right? So as you can see here, Sarah leaves immediately. That means at t equals to 0, Sarah leaves the school and heads home, right? So from the graph, we can see that Sarah covers a distance of 4 kilometers in 40 minutes, right? So it is speed of Sarah can be written as, so we can write Sarah's speed, right, is 4 kilometers. What we can do is we can convert unit to meters. So 4 kilometers is 4,000 meters divided by 40 minutes. 40 minutes, right? So that gives you 100 meters per minute, right? 0, 0 cancels out, and you get 100 meters per minute as speed of Sarah. Now to calculate Tom's speed, let's see the distance covered by Tom over the time period, right? Tom starts late. Tom starts 5 minutes after Sarah leaves, correct? Now Tom's speed is, we could write as a subscript also, Tom and the subscript speed, so speed of Tom. That's another way of writing, right? So Tom takes time duration for Tom is, this is the final point, that is the starting point, right? So he covers a distance of 8 kilometers. So I'll write 8,000 meters, right? 8,000 meters. And the time is 45 minus 5, correct? 45 minus 5, which is 40 minutes. So Tom covers double the distance in same time. Do you see that? And that gives you double the speed, right? 8,000 divided by 40 gives us 200 meters per minute, right? So that is how you calculate speed. Speed is slope of the line, right? Rise over run. So that's another way of looking into speed, right? So change in distance with time. So these are different ways of looking into speed. Rate of change, change in distance with time, slope of the line, all refers to speed, right? Steeper the graph, higher the speed, right? So Tom's graph is much steeper than Sarah's, so Tom's velocity is much higher than Sarah's. And as we calculate, it is twice as that of Sarah, correct? Now, describe their trips. To describe, let's start with Sarah. So Sarah starts immediately from school, heads home at an average or steady pace of 100 meters per minute. She covers a distance of 4 kilometers in 40 minutes, right? So that is how we can describe Sarah's ride home. Now to describe Tom's ride, we can say Tom started 5 minutes after Sarah, crossed her after another 5 minutes when they were 1 kilometer away from the school. And then Tom reached home in 40 minutes, covering a distance of 8 kilometers with an average speed of 200 meters per minute, right? So that is how we can describe Tom's ride. Note that in this description, we have mentioned when they start, when they end, how much distance do they cover, how much time they take. And we also mentioned what is their speed during the ride, right? So these are important parameters which you should cover in your description. I hope you understand and appreciate it. Thank you and all the best.